Hello guys, let's get started with a new question today, which is Dutch national flag algorithm. So the problem is we are given an array with n size which consists only three elements 0, 1 and 2, and uh, all the elements are unsorted, so it will be like 2, 2, 1, 1, 1, 0, 1, and you need to sort those elements. So the output will be 0, 1, 1, 1, 2, 2. So this will be your output. So you need to use touch a national flag algorithm. So why we will be using Dutch national flag algorithm, that is the question. So let me tell you. So if we need to sort this array, so the complexity would go order of n square, because you will be selecting the most minimum element, searching the whole array, and then finding the most minimum element in the whole array, and then we'll be swapping with an index value, and it will be going on till end of the array. So it will take order of n square, which can usually be done with selection sort, bubble sort, or insertion sort. So it can be done with this, but the requirement of the problem is that you need to only traverse the whole array at once. So it will become order of n. So you need to just reduce the complexity and make it efficient. So it should become from order of n square to order of n. So this is the question. So let's get started. Unsorted array 2, 2, 2, 1, 1, 0. Let's take this 0, 1. Okay, great. So the Dutch national flag algorithm says we will be having three pointers. The first pointer, which will be low pointer, which will be on an initial point of an array, and there will be also another pointer which will be a mid pointer, which also be that the same where the low pointer will be, and then we have a high pointer. So low will be at 0, mid will also be at 0, and high will be at n minus 1, where n is the length of an array. Great. So there will be three conditions. If array of mid, so I will write array of mid equal to 0, array of mid if equal to 1, and array of mid equal to 2. So on this criteria the whole array is sorted. So if array of mid equal to 0, we'll just swap array of low and array of mid, because most probably we want all the elements which are smaller than 1 and 2 on the left hand side, and all the elements which are greater than 1 should be on the right hand side. So all the elements which will be smaller than 1 will come on left hand side. So this all will be 0. So in middle we will be having 1, 1, 1, 1, and the elements which are greater than 1 will be on the right hand side. So by this way we'll be just differentiating all the elements, and we'll be just shifting on to the left side and the right hand side. So this is what the algorithm says for Dutch national flag algorithm, to shift all the elements which are smaller than 1 on the left hand side, and the greater than, then shift it on right hand side using a reference point which is a mid. So now if the value is 0, that means we are over here, and the initial index or initial element should be 0. So we'll just swap low and medium. So both are the same places, so we'll just swap, and then we'll just increment low as well as medium. If medium is equal to 1, so we wanted like medium should always be 1 only, because left hand side we have the lower and the right hand side we have the greater. So if mid is 1, we'll just increment mid plus plus, and if mid is 2, we need to push it onto the right hand side. So if mid is equal to 2, we need to put, so we'll just swap the values between high and mid. So we'll just put array of mid equal to array of high, and array of high is equal to array of mid. And this is all the process it does to sort the algorithm. So let me write this algorithm, so and we can start like with each iteration how this algorithm works. So we already know mid equal to 0, low equal to 0, high equal to n minus 1, while low is greater or equal to high. If, let's take array as mid, if array of mid equal to 0, we'll just swap array of low and array of high, and then we'll increment low and mid. I'm sorry, it should be mid, not high. Okay, delete low and mid. So we are shifting all the elements which are 0 on the left hand side. So hence we are just swapping the values with low and medium. So we are just shifting the medium. If there is any value on the mid, we will be just shifting onto the left hand side, which is our low value, and then we'll increment. Now if, so we'll write else if a of mid equal to 1. So we have no problem because the middle element should be 1. So we'll just increment mid plus plus. Else, so we have only one element left, this is 2. So we'll just swap the values. All the values which are greater than 1 should be on the right hand side. So we'll just swap the values from array of mid equal to array of high, and array of high will become array of mid, and then we'll decrement the high value. So let's take an example for better understanding. 2 2 2 1 0 1. We have low, medium, high. So the first iteration, so the first element is 2. So if the first element is 2, we'll be just replacing the medium value with the high, and then decrement the high value. So we'll just first swap. So let me write swap mid with high. So it will become 1, 2, same it is. Okay, so this is right now, and we'll decrement h value, which is high value. So it will become here low, medium, high. Now the value is 1. So will be in the while loop. So where is our while loop? Yes, you can see here we have while loop. So low is 0 and high is n minus 2. So high is greater, so we'll be still inside the loop and we'll just compare. So medium is 1. So if this is 1, we'll just increment medium plus or equal to 1. So if it is 1, we'll increment 1. So it will be 1 2 2 1 0 2. Low is here, medium is here, high is here. Again, low is smaller than low is smaller than high, so it will be still inside the loop, and then we'll start with medium. So medium value is 2, so we'll just swap medium and high. So it will be medium 0 2 1 2 2. We'll just, and it will be here, and it will decrement the value of high, medium, low. Still low is smaller than high. We'll be inside the loop and we'll compare medium again. So medium is 0, so we'll just swap these two values. So it will become 0, 1, 2, 1, 2, 2, and this, there will be nothing. The low will be incremented, medium will also be incremented, and low, medium, high. Okay, great. Now low is still smaller than high, so we'll continue into the loop. Now we'll again check a of medium is 2, so we'll just swap the values of mid and high. So it will become 0, 1, 1, 2, 2, 2, and we'll just decrement the high value. So our mid and high both are at the same place, and our low is also just one step back. Now a of mid is equal to 1, so mid plus 1, let's go to mid plus 1. Okay, I made a mistake. Just a small correction over here. Instead of low, we will be just having a mid. So instead of so I just got to know when I was just when the medium and the low were interacting, I mean intersecting with each other. So instead of low, we will be comparing the value with high. So till here everything is fine, till here, till this area everything is fine. So if you see 0, 1, 2, 1, 2, 2, medium and high and low. Okay, cool. So let's see this. So medium is still lower than high, medium is 2, we'll just swap the value, so it will become 0, 1, 1, 2, 2, 2, and at this moment medium and will just also decrement the h value, so medium and high will all be at the same place and low will be here. And then we'll see medium is here, high is here, a of mid equal to 1, so mid will be incremented. So as soon as mid comes here, now the medium is greater, mid is greater than high, which violates the condition of while loop, which is medium, and the loop get terminated, and then you can return this whole array. So this is how the Dutch national flag algorithm works, and we have our algorithm over here. So you can see we have implemented the low, medium and high, and a small check if array is equal to 0 or less than 0, so we should return -1, else we'll just write our algorithm. So let's try to run the code, and you can see all the test cases have been passed. Let's try to submit. And let's wait. Okay, so it was accepted and all the test cases have been passed. Okay, make sure, so this is not the great runtime, but you can even optimize it more further if you want. And that's it guys. So if you have more optimized solution for this, feel free to drop in our comments, and the better one will be pinned at our description, sorry, in the comment. And that's it guys for today. Thank you so much.